So I had given you this problem, right, last class. So you have to find the convolution of x of n and h of n using the graphical method. Are you able to view the screen, guys?
Yes, ma'am.
Yeah. So solve the convolution sum or solve the convolution using graphical method. So if they have explicitly mentioned to do using graphical method, I will show you this method, or else there is one simple method that you can do. Okay, so if they didn't mention any method, you can do any method, graphical or that simple method. If they have mentioned graphical method, then do graphical method only. Okay, so you can see that both the sequences x of n and h of n both are finite. Okay, so first what you have to do is we are solving the convolution by plotting the graph of this x of n and h of n. So we have to know what is y of n. So y of n will have how many terms we will have. We have to know that. Okay. So this first sequence x of n is of length. How many numbers are there in this? This sequence is of length L. Okay. If x of n is of length L and h of n is of length m. Okay, it is 3 here and it is 5 here. So your convoluted sequence y of n will be of the length L plus m minus 1. Okay, so this is this thing you have to remember. If x of n is of the length L and if h of n is of the length m, then y of n, that is the convoluted sequence, will be of the length L plus m minus 1. Okay, so they have also given you the origin. Where is the origin here? So our convoluted sequence will be of the length 5 plus 3 minus 1, that is 7. Y of n will have 7 samples. Okay, now we have to know what is the origin of that sample. Okay, here we are giving they have given the origin for x of n and h of n, and we have found out the length of y of n, that is 7 samples. 5 plus 3 minus 1 gives you, this is the formula to find out the convoluted sequence. Okay, the number of samples of convoluted sequence. Okay, so your convoluted sequence will have L plus m minus 1, that is 5 plus 3 minus 1, 7 samples. And where is the origin for that y of n? We have to see. See, as you can see here, observe carefully. This is at n is equal to 0, n is equal to 1, n is equal to 2. This is at minus 1, minus 2. This is at minus 1, this is at 0, and this is at plus 1. You people know this, right? If you have like this, so if you have a sequence like this, if you have an arrowhead that represents the at n is equal to 0, right? So right to that will be 1, 2, left to that will be negative values of n, minus 1, minus 2. So your origin will be, you're having 7 samples. So your origin will be, so what is the first sample you have to know? Where y of n will start with which value you have to know. So add this to the left of n is equal to 0. How many sequences you have here? How many values you have here? Here you have 1, here you have 1 and 2. So 2 plus 1, it is 3. So y of n will start from minus 3, minus 2, minus 1, 0. And to the right of 0, you have here 2 values and here 1 value. So right of 0 will be having also 3 values. So it's 1, 2, 3. Got it, everyone? Is it clear?
Yes, ma'am.
So this is the convolution using graphical method. So whenever they give you a problem using convolution using graphical method, find the length of x of n and h of n and try to get the length of y of n using this formula L plus m minus 1. L is the length of x of n, m is the length of h of n. Okay, so put this formula L plus m minus 1, you'll get the length of y of n. After getting the length, you have to know where is our first sample, from where it is starting. Okay, so it is starting to evaluate from where will the first sample start. So check the values to the left of 0 on both x of n and h of n. Here you have 2, here you have 1. So 2 plus 1, it is 3. So it starts from -3, -2, -1, again 0. Again to the right, how many values you have? 1, 2 and 3. So you have 1, 2, 3. Got it? It's clear till here? So our y of n will start from -3 and it will go up to 3. Clear? So you have 7 samples. Did you follow? It's clear? Understood this one, everyone?
Yes, ma'am.
Now what you have to do is, I need to put the values of n for y of n, and I have to take these values and put it in the equation, our convolution sum equation. Okay, so we shall start. If it's clear for you till here, we can start the graphical convolution. It's clear now? So what is the formula for convolution sum? That is summation k is equal to -infinity to infinity x of k into h of n minus k, right? Now wherever I have n, I am putting the values of n. First I'll put -3, -2, -1, then 0, 1, 2, 3. So I'll check the convolution of that. Okay, so y of, first I'll take n is equal to -3. So y of -3 is equal to summation k is equal to -infinity to infinity x of k into h of -3 minus k. Got it? This is our convolution sum equation. I am putting n is equal to -3. So y of -3 is equal to summation k is equal to -infinity to infinity x of k into h of -3 minus k. Now plot these values, x of k and h of -3 minus k. Okay, what is x of k? This is your x of k or x of n. Okay, so in convolution where our x-axis is k, right? So we will take this as x of k, and h of n is also known. So you have to plot h of -3 minus k. So before that, you first plot what is x of n and h of n. Then you plot h of -3 minus k. Okay, let us plot what is x of n. It is -1, 1, 0, 1, -1. So x of k is 0, -1, -2, 1 and 2. So it is -1, 1, 0, 1 and -1. Got it? Clear everyone? This is -1, this is +1. This is our x of k. Now you plot h of k, h of n. H of n is, they have given that h of n is or h of k you can take. Okay, h of k is, it is at 0, it is 2. Okay, at 0 it is the value of h of k is 2. At -1 it is 1, and at 1 it is 3. Right? So this is our x of k and h of k. So we have taken what is x of n and h of n and plotted accordingly x of k and h of k. So now you have to plot h of -3 minus k and check the overlapping space between x of k and h of -3 minus k. So whatever is overlapping, that is your y of -3. Okay, got it everyone? Try to plot h of -3 minus k. How will you plot this? So we are fixing x of k and varying this one, h of n minus k. Okay, we are fixing x of k, varying h of n minus k according to our values of n. Here I have taken n is equal to -3 now. So in place of n I have substituted -3. Now I will find, I'll multiply these two and I'll try to find which samples are overlapping, and I'll get y of -3. Okay, so try to plot h of -3 minus k. So to plot h of -3 minus k, what will you plot first?
H of k minus 3, ma'am.
Yes, plot h of k minus 3, then time reverse that to get h of -3 minus k. Okay, so h of k minus 3 means, from where will the signal start? Sorry, it is at -1 here. So h of k minus 3, where it will start?
+2, ma'am.
Yeah, it is right shift by 3 instants, right? So it will start from +2. So at +2 you will have 1. At 3 you will have 2. And at 4 you will have 3. Got it? Now you time reverse that. Take time reversal of this. You will get h of minus k minus 3. H of minus k minus 3 is time reversal of this. So time reversal or reflection means your signal will be present from -4 to -2. So at -4 you have 3, at -3 you have 2, and at 2 you have 1. Got it, everyone? Now you check. Our waveforms of interest are x of k and h of k minus 3. Okay. So now what you have to do is you have to multiply these two. Here multiplication of x of k and h of minus 3 minus k is there. So multiply these two and check where is the overlapping space. So from minus infinity to infinity, where are these signals overlapping? X of k and h of minus 3 minus k, h of minus k minus 3 or minus 3 minus k, both are same. So where is it overlapping these two? It's overlapping at -2, right? So at -2 it is overlapping. So I can write y of -3 is equal to, here at -2 you have -1, here at -2 you have 1. So -1 into 1 it is -1. So y of -3 is equal to -1. Got it? Here at y of -3 my value is -1. You have to find like that for up to 3, why n is equal to 3. So we have found for n is equal to -3. Next you find for n is equal to -2. It's clear, everyone? Check the overlapping space between x of k and h of -3 minus k. So where is this overlapping? Only at -2 it is overlapping, because here for negative values you don't have anything. It is 0. Here it is 0 for right side of -2 is also it's 0. Only it's overlapping at -2. Here you have -1, here you have +1. So multiply these two. -1 into 1 you will have -1. Got it, everyone? Clear? This is the first step. Clear or not? Guys, reply it's clear or not, or you want me to explain once again? Clear? Now take n is equal to -2. Same way you do. So if n is equal to -2, so what will you get? Y of -2 is equal to summation of k is equal to -infinity to infinity x of k into h of -2 minus k. Okay. So plot this h of -2 minus k. X of k you know. Plot h of -2 minus k and check the overlapping space. How will you plot h of -2 minus k? You have h of -3 minus k. Here -2 minus k means it will be one shift to the right, right? So it will start from -1, -2 and -3. So this is 3, 2, 1. Or else you can also do h of k minus 2 you do and take time reversal of that to get h of -k minus 2. You can do like this also, or if you get one instant you can shift it accordingly. Got it? So our waveforms of interest are x of k and h of -2 minus k. This one. Now check the overlapping space. What is y of -2? Where it is overlapping? Where is these waveforms overlapping, guys?
At -2 and -1 now.
At -2 and -1. So at -2, what you have here? So at -2 you have -1. Here at -2 you have 2. So -1 into 2, -1 into 2 plus at -1 it's overlapping, right? So at 1 into 1, correct? plus 1 into 1. So y of minus 2 is minus 2 plus 1, it is minus 1. Got it? It's clear? Check the overlapping space, okay, and multiply these two or do multiplication for these two. This and this. So where are they overlapping? You have to multiply at each instant. At minus 2, here you have minus 1. Here at minus 2, you have 2. So minus 1 into 2 plus at minus 1 also it's overlapping. 1 into 1. 1 only. So minus 2 plus 1 is minus 1. It's clear? It is clear, guys?
Yes, ma'am.
So now put n is equal to minus 1. N is equal to minus 1 you put. So y of minus 1 is equal to summation k is equal to minus infinity to infinity x of k into h of minus 1 minus k. So it will be one shift to the right again. Okay. Or you can plot h of k minus 1 and take time reversal of that. You'll get h of minus k minus 1. Okay, so h of minus 1 minus k will be one shift to the right. So it will be starting from 0, 1, 2 and 3. So this is minus 1, minus 2, 0. Okay, now you check the overlapping space between this x of k and h of minus 1 minus k. I will plot x of k here for your reference. X of k is, sorry, it's plus 1, minus 2, plus 2. So it is at minus 1 it is 1, at plus 1 also it is 1, at minus 2 it's minus 1, at minus 2 it's minus 1. This is your x of k. Now check the overlapping space, where it is overlapping. What is the overlapping space? Y of minus 1. Where are the signals overlapping? So at x of k it is 0, at n is equal to 0. So where are they overlapping? They are overlapping at minus 2, minus 1 and 0. So at minus 2 here you have minus 1, minus, okay, this is understood, minus 1 plus 1. So at x of minus 2 here you have minus 1 and here x of 2 you have 3. So minus 1 into 3 plus at minus 1 here you have 1, here you have 2. So plus 1 into 2 plus here at 0 you have 0, here you have 1 plus 0 into 1. Okay, so what do you get? You have minus 3 plus 2, so it's minus 1. So y of minus 1 is also minus 1. Got it? Are you guys following?
Excuse me, ma'am.
Yes, tell me.
Ma'am, at 0, it cannot be 1, ma'am. Amplitude. Oh, okay,
Where?
ma'am. I got it, ma'am. I got it.
Yeah. X of k signal is only minus 1, 1, 0, 1, minus 1. Correct?
Yes, ma'am.
So it is 0 here. 0 into 1 is 0 only. At minus 1 you have 1 here, here you have 2. So 1 into 2 you get 2. And at minus 2 you have 3 here and minus 1 here. So minus 1 into 3 you have minus 3. So minus 3 plus 2 plus 0 is minus 1. Got it, everyone? Got it? Now you take n is equal to 0. N is equal to 0 you put. So y of 0 is nothing but summation k is equal to minus infinity to infinity x of k into h of, what do you get? H of minus k, right? H of n minus k. N is 0 means you are left with minus k. Okay, h of minus k is just the reflection, right? Reflection of h of k. Or one, yeah, reflection you can take, or one shift to the right you can take. So here you have 1, 0, minus 1. With respect to this, I'm telling you shift. Okay, or else you can take h of k time reversal of h of k, which you have plotted at the beginning. So here you have 3, here you have 2, and here you have 1. This is h of minus k, and you have x of k here. Check the overlapping space. What is the overlapping? What is y of 0? Overlapping is from -1 to +1, right? -1, 0, +1. So, right, at -1 you have 1 in x of k, and at h of minus k you have 3, plus at 0, at k is equal to 0, you have 0 into 2. Here you have 2 here, so it is 0. Plus at 1 you have 1 here, and there also you have 1. Here also you have 1. Here also you have 1. So y of 0 is how much? It's 3 plus 1, 4. Got it? So at y of 0, at n is equal to 0, your amplitude will be 4. Is it clear, guys? You are following or not? You have to tell me.
Following, ma'am.
Okay. So now n is equal to 0 is done. Now do n is equal to +1. Like that you have to do till n is equal to 3. So if n is equal to 1, you have y of 1, which is equal to summation k is equal to minus infinity to infinity x of k into h of 1 minus k. How will you plot h of 1 minus k? H of k plus 1 you do, and then time reverse that to get h of 1 minus k. Or you are having h of minus k, right? So shift one place to the right, this one. Okay, if you get confused, do like this only. Later you can do like this. So if you do one correctly, first one, h of minus 3 minus k, then you can be shifting one step to the right. Okay. So h of 1 minus k will be, h of 1 minus k will look like this. So one shift to the right with respect to h of minus k. Okay. So at 0 you have 3, at 1 you have 2, and at 0 you have 3, at 1 you have 2, and at 2 you have 1. This is h of 1 minus k. X of k is, at 0 it is 0, at -1 and 1 it is 1, and at 2 and -2 it is -1. Now check the overlapping space. Y of 1 is equal to, where it is overlapping? 0, 1 and 2. So what is y of 1? You have to tell me.
2, ma'am.
2 or 1?
1, ma'am.
So at 0 it is overlapping. At 0 it is 0 into 3. Okay. Plus at 1 it is 1 into 2. Plus at 2 it is -1 into 1. So 2 minus 1, it is nothing but 1. Y of 1 is 1. Got it? Clear?
Yes, ma'am.
Now you do n is equal to 3, n is equal to 2. So y of 2 is equal to summation k is equal to minus infinity to infinity x of k into h of 2 minus k. So just one shift to the right it will be. So h of 2 minus k. So whatever is at 0 will go to 1. So you will have 3 at 1, at 2 you will have 2, and at 3 you will have 1. So 3, 2, 1. Now check the overlapping space. Our waveforms of interest are x of k and h of 2 minus k. What is the overlapping space? Y of 2 is
-1, ma'am.
-1 or +1?
+1, ma'am.
+1, right? So it's overlapping at 1 and 2, right? At 1 you have 1 into 3, and at 2 you have -1 into 2. So 3 minus 2 is 1. So y of 2 is 1. Got it, everyone? Clear? It's clear or not? It's clear till here? So
Yes, ma'am.
lastly, you take is equal to 3. So y of 3 is equal to summation k is equal to minus infinity to infinity x of k into h of 3 minus k you do. So h of 3 minus k will be one shift to the right. So it will start from 2, 3 and 4. It will exist till 4. So it is 3, 2 and 1. So now check the overlapping space between x of k into h of 3 minus k. I'll draw x of k here for your reference. At minus 1 and plus 1 it is 1, and at minus 2 it's minus 1. Sorry. Minus 1. So where it is overlapping?
At 2, ma'am.
Overlapping is at 2. 2 alone. So it is 3 into, so it is 3 into minus 1, right? So y of 3 is nothing but at plus 2 it's overlapping, right? So at minus 1 into 3 will be minus 3. Got it, everyone? It's clear? Convolution by graphical method. Now
Yes,
tell me the
ma'am.
values of y of n. From minus 3 to 3, what all we have got, you tell me. Y of minus 3 is
-1,
minus 1. What is y of minus 2?
-1,
Y of minus 1.
-1,
Y of 0.
4,
4, ma'am.
Y of 1.
1, ma'am.
Y of 2.
1, ma'am.
And y of 3, it's minus 3. Got it? So this is your convolution. N is equal to 7 samples and origin is at, this is at n is equal to 0. Okay. Hello students, am I audible?
Yes, ma'am.
I lost the connection. I'm trying to reconnect. Give me 5 minutes. You guys can plot that y of n meanwhile. Okay, I'll join now. Are you able to view the screen?
Yes, ma'am.
Okay. So we had seen a problem on graphical convolution for finite sequences. Okay, so the x of n is of length L and h of n is of length m. So y of n will be of the length L plus m minus 1. Okay, so it will be of length 7. And what is the first sequence is? How to evaluate that? To the left of 0, how many values you have? Add that 1, 2, 3. So it's starting from minus 3, and to the right of 0 you have 3 values, so it will be ending till 3. Okay, so you have 3 values to the left of to the right of 0. So first what we did, we substituted the value of y of n to be minus 3. So we got this equation, y of minus 3 is summation k is equal to minus infinity to infinity x of k into h of minus 3 minus k. So x of k is known, h of k is also known. H of minus 3 minus k will be, how will you plot this h of minus 3 minus k? First plot h of k minus 3, then time reverse that to get h of minus k minus 3. Okay. So now check where is the overlapping between these two. This is our waveform of our interest, x of k and h of minus k minus 3 or minus 3 minus k, h of minus 3 minus k. So check where is the overlapping. The overlapping is only at 2, right, for this and this. So it is minus 1 into 1, it's minus 1. Okay. So similarly we did n is equal to minus 2 and check the overlapping space. So shift this one step right. Okay, h of minus 2 minus k. So what is the overlapping space? It is at minus 2 and minus 1. So at minus 2 here you have minus 1 and here you have 2. So minus 1 into 2 plus at minus 1 you have 1 into 1. Okay, so y of minus 2 is minus 1. So similarly we did for n is equal to minus 1. So y of minus 1 will be summation k is equal to minus infinity to infinity x of k into h of minus 1 minus k. So one step right you shift. It will be starting from 0. From minus 2 to 0 it will exist. So you check the overlapping space between this and this, or multiply these two, x of k and h of -1 minus k. So where it is overlapping, you can see -2, -1 and 0. This also -2, -1 and 0. So at -2, -1 into 3 plus at -1 you have 1 into 2 plus at 0 you have 0 into 1. So you will get y of -1 as -1. Similarly, at n is equal to 0, y of 0 is summation k is equal to -infinity to infinity x of k into h of minus k. H of minus k means you can take time reversal of h of k, or you can shift this one step right. Okay. So where is the overlapping? You check. It is from -1, 0, right? So wait, the overlapping is from -1, 0 and 1, these three. Okay, so at -1 you have 1 into 3, at 0 you have 0 into 2, at 1 you have 1 into 1. Okay, check the samples at each instant. So what is their amplitude? Multiply their amplitudes at each instant. At -1, check the amplitude of both, multiply that. At 0, check the amplitude of both and multiply that. Multiply the amplitudes only. Okay, and at +1, amplitude is 1 and 1, so you have 1 here. So y of 0 will be 4. Similarly, do for y of 1, that is n is equal to 1. You get summation k is equal to -infinity to infinity x of k into h of 1 minus k. Okay, this is x of k, this is h of 1 minus k. So now check the overlapping space between these two. It's 0, 1 and 2. At 0, the amplitude there is 0, here it's 3. So 0 into 3 plus at 1 you have 1 into 2 plus at 2 you have -1 into 1. Okay, so you'll get +1. So if n is equal to 2, similarly, so y of 2 is summation k is equal to -infinity to infinity x of k into h of 2 minus k. H of 2 minus k is one step right shift, the whole sequence. Okay, or you can also do h of k plus 2 and take time reversal of that. Okay, you can do either ways. So better you do like this, one step to the right, else you will have a lot of waveforms, it will be very confusing. So check the overlapping space between x of k and this one. It's overlapping at 1 and 2. So at 1 you have 1 here and you have 3 here. 1 into 3 plus -1 into 2. At 2 you have -1 here and 2 here. So -1 into 2. So overlapping spaces only 2 instants. So you get 1. So at n is equal to 3, similarly you will have overlapping only at 2. This is one shift right with respect to h of 2 minus k, h of 3 minus k. Okay. So overlapping space is at only +2. So it's 1 -1 into 3. It's -3. So we have got our samples from -3 to +3. Now try to plot that. Did you guys plot it? Y of n would be at n is equal to 0. It's 4. At 1, this is at 1, 2, 3. This is at -1, -2, -3. So at -1, -2, -3, it's -1 only. At 0, it is 4. At 1, it is 1. At 2, also it is 1. And at 3, it is -3. Got it? This is the convolution. Followed convolution by graphical method for discrete time signals. Understood, guys?
Yes, ma'am.
It's clear? So first what you are doing when x of n and h of n is given, check the length of x of n and length of h of n. So y of n will be of the length l plus m minus 1. So y of n you have to check from where it will start. Okay, so you have to check where is the first sequence and where is the last sequence. Okay, it is clear till this one, graphical convolution for discrete time signals. So I will show you one more method of convolution. You can try graphical convolution for that. Okay, you can take that as homework and you can try. So x of n is equal to 1, 2, 3 and 4. So origin is at 2. Okay, and h of n is equal to 1, 5 and 1. Okay, this is at origin. 1 minute. I think it's 5. I'm sorry. Yeah, it's 5. Origin is 5. So you have to find the convolution of this x of n and h of n. Find the convolution sum or find the convolution of x of n and h of n. If this is given, if they give only this much, you can use a simple method which I'll show you now. If they tell you to do a graphical method, you have to do graphical method only. Graphical method will it's of 10 marks, graphical method. Okay, if they give for graphical method, it will be given for 10 marks. If they ask you not like this, you can use normal method. Okay, so as you can see here, so what is the length of x of n? What's the length of x of n?
4.
It is 4, and the length of h of n is 3. So your convoluted sequence y of n will be of the length l plus m minus 1. So 4 plus 3 minus 1, it will be of the 6, length 6. Y of n has length 6. Okay, so let us see how to do the convolution in a simple method. So what you have to do is you have to take convolution is nothing but summation and multiplication, right? So you have to take horizontally and vertically x of n and h of n. Okay, so I'll take x of n vertically, these terms, and h of n terms horizontally. So I'll write the terms of x of minus 1. So the x of n is existing from minus 1, 0, 1 and 2. This is from minus 1, 0 and plus 1.
And the arrow mark is given or we should consider?
They will be given. You should not consider. It will be given.
Yes, ma'am.
Okay. X of 0, x of 1, x of 2. So the values are 1, 2, 3 and 4. And horizontally, if you take h of minus 1, h of 0 and h of 1, you have 1, 5 and 1. Okay. Now you multiply each row with each column. So 1 into 1 is 1, 1 into 5 is 5, 1 into 1 is 1, 2 into 1 is 2, 2 into 5 is 10, 2 into 1 is 2, 3 into 1 is 3, 3 into 5 is 15 and 3 into 1 is 3, 4 into 1 is 4, 4 into 5 20 and 4 into 1 is 4. Now what you have to do is you have to draw like horizontal lines like this. Okay. So draw horizontal lines like this and add each row like this. Okay, so your y of n will be equal to 1 and 5 plus 2 it is 7. Then you have 10 plus 3 plus 1 14. Then you have 15 plus 4 plus 2 21. Then you have 20 plus 3 23 and 4. So as you know, as you can see, we have got 6 samples. And where is our origin? Where is the origin for this y of n? How will you tell where is the origin for y of n? Here the origin, yes?
14.
The origin is at 14. Okay. So how it is at 14 means to the left of this 0, you have 1 here. To the left of 0 in this x of n also you have 1 here. So 1 plus 1 it is 2. So after 2 values you will have the origin. Okay. So here you have 2 values. To the right you have 2 values here and here 1. So to the right of 0 you will have 3 values. So this is at n is equal to 0. So the homework for you is you have to try graphical method for this. Okay, take this as homework, or you can use this simple method for verification of your convolution, whether you have done correctly or not. Okay, it is very simple. It will take 2 minutes, hardly 2 minutes. So you can use this method for verification. If they are given graphical method, solve it using graphical method and you can verify using this method. Okay, so take homework and try this graphical method. Graphical method of convolution you try. Got it? Understood this method, everyone? Simple method. Is it clear, everyone? Guys, please respond. It's clear or not, you have to respond. Okay, take the x of n terms vertically and h of n terms horizontally. Try multiplying each row with these one, each sequence with each h of n sequence. Then you draw the vertical line, draw lines like this. Okay, cross lines like this, and add each cross. Okay, each block you add it, you'll get the convolution. If you want, you can try using graphical method. You have to get the same y of n. Okay. So that is about the convolution. We'll solve some more problems in our future classes. So let us now go to convolution integral today. Okay. Till here it's clear now, all the methods. I'll also share the textbook PDF. You can solve more problems. I'll also solve some problems after I complete this one, convolution integral. And all, if I teach you the main concepts, later we can solve problems. We can solve all the problems in a mixed fashion, convolution sum and convolution integral. Till here it's clear, everyone?
Yes, ma'am.
So now let us see convolution integral. So when I did convolution sum only, I told you. So convolution integral and convolution sum are same. There you have summation, but that summation will be replaced with integration here. That's the main difference. All others are same here. So convolution integral is a counterpart of convolution sum. Okay. So convolution sum is performed for discrete time signal. So it's x of n convolved with h of n, which gives you y of n. Whereas in convolution integral, it is for continuous time signals. So if you have x of t, if you convolve with h of t, you get y of t. Okay, now let us try to derive the expression for this convolution integral y of t. Okay, so we have seen that in our convolution sum, if you are giving input x of n to the system, you get y of n, right? The system, your input signal will undergo some transformation and you will get y of n. So y of n was the transformation on x of n, right? So similarly for continuous time signals also, so if you give x of t to the system, LTI system, okay, that is linear time invariant system, you get y of t. So we can say y of t is nothing but the transformation on x of t. Got it? So if we, so for what did we do for this impulse response representation? Here we gave impulse signal, we got impulse response. Response to that impulse signal, that is called impulse response. Similarly, here we'll give delta t, that is impulse signal to the system. Then output what you get will be the response to that impulse signal, that will be impulse response h of t. Okay, so if input is an impulse signal and output will be the response to that impulse signal, that is called as impulse response. So y of t is a transformation on x of t. So we have seen what is the equation for x of n, right? So x of n was nothing but summation k is equal to minus infinity to infinity x of k into delta of n minus k, right? We took one discrete time signal and we took that in the form of impulse response of time shifted impulses, right? So this was the sample amplitude and this was the shifted version of impulses. Okay, so the sum of samples is multiplied with the shifted version of impulses, right? So your x of t is also similar to that. X of t is equal to integral minus infinity to infinity x of tau into delta of t minus tau into d tau. Okay, so we are replacing n with t here. That's the difference, that's all. And k with tau. You can take k also here. Okay, if you take k, you'll get x of t is equal to integral minus infinity to infinity x of k into delta t minus k into dk. But better it will take tau only, this equation will take. So just we are replacing n with t, that's all. That's the main difference. And we have replaced our k with tau. Or you can keep it as it is, or you can take tau. Because it will be helpful for differentiation, let it be tau. Okay, to differentiate from this, you will not get confused. So let it, for this integral, we'll take x of t is equal to integral minus infinity to infinity x of tau into delta t minus tau into d tau. Okay, so now what we are doing is y of, we will try to get y of t. So y of t is nothing but the transformation on x of t. So in the place of t, put this equation. So y of t is the transformation on integral minus infinity to infinity x of tau into delta t minus tau into d tau. Okay, so if we if you take this out, we'll have integral minus infinity to infinity x of tau into transformation on delta t minus tau into d tau. So what if our signal is impulse, the output will be response to that, right? Impulse response. So transformation on delta t is nothing but h of t minus tau, impulse response. So y of t is nothing but, if the input is delta t, output will be h of t. So if your input is delta t minus tau given to the system, then output will be h of t minus tau. That's all. So y of t is minus infinity to infinity x of tau into h of t minus tau into d tau. So transformation on delta t minus tau is h of t minus tau. This is the impulse signal and this is the response, impulse response. So this is your equation for convolution integral. Got it, everyone? So they'll give you x of t and h of t. Okay, you have to find y of t, convolution of x of t and h of t. It's clear, everyone? It's clear or not?
Yes, ma'am.
You want me to explain once again convolution integral, or it's clear? You want me to explain once again, or it's clear, guys?
Ma'am, it's clear.
Okay. What about others?
It's clear, ma'am.
Okay. So we shall try solving few problems on convolution integral. Okay. So take down the first problem. Find the convolution integral of h of t, which is given to be u of t, and x of t is equal to e power minus at into u of t, where a is greater than 0. You have to find the convolution integral. Find the convolution integral y of t and plot it. Yeah, and you have to plot whatever you get y of t. Okay, this is the given question. So we have to find the convolution integral, that is y of t. So we are giving x of t to the system, LTI system, and we are getting the output y of t. Okay, so y of t is nothing but the convolution of x of t convolved with impulse response. Okay, input convolved with impulse response will give the convolution integral. Okay, so take down the equation for convolution integral, minus infinity to infinity x of tau into h of t minus tau into d tau. So this is the equation. Now, so what is our x of t term? This is e power minus at into u of t. So wherever you have t, replace it with tau. Okay. In h of t term, wherever you have t, replace it with t minus tau. Okay. So you have y of t, which is equal to integral minus infinity to infinity e power minus a tau into u of tau into u of t minus tau into d tau. Got it? H of t term is u of t. X of t term is e power minus at into u of t. So in x of t term, we are replacing t with tau. In h of t term, you have u of t. We are replacing t with t minus tau. Clear? It's clear or not?
It's clear, ma'am.
Now you try to plot this u of tau into u of t minus tau. Okay. So we'll try to fix one variable and try to plot the another variable. Okay, so try to plot this u of tau into u of t minus tau. So u of tau means nothing but u of t, unit step. Okay, so tau is your x-axis here. So it will exist from 0 up to infinity with an amplitude 1, u of t or u of tau, unit step signal. How will you plot u of t minus tau? How will you plot this?
First tau plus t, ma'am, and then time reversal.
Yes, correct. So first you will plot u of tau plus t, then take time reversal. Okay, tau plus t means from where to where it will exist? From minus t to infinity. Got it? So now you time reverse this. You have to know shifting and all well. Okay. So that is the basics. So if you take time reversal of this, your signal will exist from minus infinity to t. This is u of t minus tau. Got it, everyone? Clear? Your x-axis is replaced with tau. That means t is replaced with tau. Don't get confused. Here this t is some delay. Okay. This is some value or constant. Like how you plot u of t plus 3 minus t. Okay, it is like that. You'll plot u of t plus 3, then u of 3 minus t, something like that. Okay. So is it clear, everyone? So now our waveforms of interest are u of tau and u of t minus tau. Okay. So we'll fix this waveform u of tau and we'll vary u of t minus tau with respect to t. Got it, everyone? So since these both sequences are infinite sequences, so we'll have two cases. Okay. So what is the case one? So we are fixing this. This waveform is fixed. You have to vary this waveform with respect to this. So how will you vary? What is the case one? Case one is if t is less than 0. Okay. If t is less than 0, what happens? You have u of tau, and if t is less than 0, you will have a waveform something like this. This will be u of tau into u of t minus tau. This is t. From minus infinity to t, it's existing, and our u of t is existing from 0 up to infinity. So what is the overlapping space?
0, ma'am.
There is no overlapping between this signal and this signal if t is less than 0. If t is some negative value, okay, there is no overlapping space between these two. So y of t will be equal to 0. Okay. So is it clear, case 1? So let us see case 2. If t is greater than or equal to 0, what happens? So we'll take case 2, t greater than 0. So what is the overlapping space between this and this signal and this signal? Overlapping space
0
is
to t, ma'am.
0 to
T.
t. So if you overlap that, this is u of tau, and if you overlap u of t minus tau, it will be some from minus infinity to t. So this is from minus infinity to t, and this is from 0 to infinity. So what is the overlapping space? It is from 0 to t. Okay. So we can take y of t is equal to integral 0 to t. What was our y of t previously? It was e power minus a tau into 1 into d tau. This amplitude is 1, right? Unit step. It's by default 1. Okay. So y of t is the integral from 0 to t, because it's existing from overlapping from 0 to t. Integral 0 to t e power minus a tau into 1 into 1 into d tau. So now you find the integration of e power minus a tau. What do you get? If you integrate this, what will you get? E power minus a tau. If you integrate e power minus at, what you will get? E power minus at by minus a, correct? Yes or no?
Yes, ma'am.
Yes, ma'am.
So you have e power minus a tau divided by minus a with limits 0 to t. Okay, so now try solving this. So I will take minus 1 by a outside. So you have e power minus at minus e power minus 0. Correct? So e power minus 0 is 1. So you have minus 1 by a into e power minus at minus 1, or we can take negative sign. We can multiply this once again and you can take it is equal to 1 by a into 1 minus e power minus at into u of t, because the signal is starting from 0. Got it?
Ma'am, you told it is not here from 0, u of t.
Yeah, if you can write, okay, if you want, you can, better you write it, okay? Because directly if I write for u of t minus 2 or something, you will be wondering why I'm writing. So better you write it.
Yes, ma'am.
Okay, so now we have to plot this y of t. Our y of t was found to be 1 by a, 1 minus e power minus at into u of t, right? So how do we plot it? Did you all understand this problem? Shall I brief up once? So you have been given with h of t, it is unit step, and x of t is e power minus at into u of t, where a is greater than 0. You have to find the convolution integral, that is y of t, and you have to plot it. So we shall see the plotting. First understand this problem. So convolution integral formula is y of t is integral minus infinity to infinity x of tau into h of t minus tau d tau. So what we have to do is x of t terms we have to replace t with tau, and h of t terms replace t with t minus tau. That is what we have done. So now this multiplication we have to plot u of tau into u of t minus tau. Okay, our convolution will depend on this only. So plot u of tau and u of t minus tau. How will you plot u of t minus tau? First you plot u of tau plus t, then time reverse that, you get u of t minus tau. Okay, u of tau is unit step. It exists from 0 till infinity with an amplitude 1, whereas u of t minus tau will exist from minus infinity to t with an amplitude 1. So we are fixing this and varying this with respect to this waveform. Okay, so case 1 will be t less than 0. If t is less than 0, you can see this how we can multiply these two. So if t is less than 0, or you can take this minus t. Okay, so don't get confused. There is no overlapping space. Okay, so y of t is 0. So if t is greater than or equal to 0, if I multiply these two, what is the overlapping space? The overlapping space is from 0 to t. So my u of tau is existing from 0 to infinity, and u of tau minus t is existing from t minus tau. T minus tau is existing from minus infinity to t. So if you multiply those two, the overlapping space is 0 to t. Okay, so I have taken integral 0 to t e power minus a tau into 1, because the amplitude of u of tau into u of t minus tau is 1 into d tau. So if you integrate this, you will get e power minus a tau by minus a with limits 0 to t. So take 1 by minus a out and put in place of tau, replace upper limit minus lower limit. So e power upper limit is e power minus at minus lower limit is e power minus a into 0. So this e power minus 0 is 1. So you get y of t, which is minus 1 by a, e power minus at minus 1, or you can get rid of this minus sign. You will get 1 by a into 1 minus e power minus at into u of t. So now we have to plot it. How will you plot it? This is y of t. So at t is equal to 0, if t is equal to 0, you will get 1 by a into 1 minus e power 0, right? So 1 by a into 1 minus 1 is 0. So at t is equal to 0, the y of t will be 0. Okay, and this will, and that you can evaluate at t is equal to infinity. So e power minus infinity is 0. So you have 1 by a into 1 minus e power minus infinity, which is 0. So you have 1 by a into 1. So at t is equal to infinity, your waveform will be 1 by a. Okay, so at infinity, your signal will be equal to 1 by a. So this is the plotting of this y of t. Got it, everyone? So the meaning is the waveform will approach 1 by a at t is equal to infinity. The amplitude will be 1 by a at t is equal to infinity for y of t. Got it? Because why we are multiplying u of t means because our signal is starting from t is equal to 0. Understood, everyone? It is clear? Is it clear or not? Others, it's clear?
Yes, ma'am.
So if it's clear, we can go to next problem. So find the convolution integral of h of t, h of t is equal to e power minus t into u of t, and x of t is equal to e power minus 3t into u of t minus u of t minus 2. So you have to find the convolution integral of h of t and x of t. You have to find y of t. Okay, so first when a problem is given to you, try to check if it's finite or infinite sequence. So what type of sequence is this h of t?
Infinite, ma'am.
It's infinite sequence. What about this x of t? U of t minus 2 into e power minus 3t you have. It's finite or infinite?
Finite, ma'am.
It's
It is
finite
also infinite,
sequence.
ma'am.
It's finite sequence, right? U of t minus 2 will be a signal from 0 to 2, right? With an amplitude 1. That into e power minus 3t will be finite only. So if you have finite sequence and infinite sequence, how many cases will you have? I told you at the beginning. If one sequence is
Yes, sir.
infinite, other is finite, how many cases you will have?
3 cases.
You will have 3 cases, correct? So we'll try to find the convolution and we shall see how to take these cases and all. Okay. So take the formula for convolution integral. Y of t is equal to integral minus infinity to infinity x of tau into h of t minus tau into d tau. Okay. So what is the x of t term? Replace t with tau. In h of t term, replace t with t minus tau. Okay, always try to keep the less number of terms in this h of t. Okay, because if you do t minus tau for this, it will be a very huge. So here it's proper. Suppose they give this as h of t, this as x of t, you can reverse that. Okay. So because according to commutative law, x of t into convolved with h of t is same as h of t convolved with x of t. So here it is proper. Okay. So now replace this x of t terms wherever you have t with tau. And in this you replace wherever you have t with t minus tau. So write that equation. Y of t is equal to integral minus infinity to infinity e power minus 3 tau into u of tau minus u of tau minus 2 into e power minus t minus tau into u of t minus tau into d tau. Got it? Is it clear? I am replacing x of t terms. Wherever I have t, I am replacing it with tau, e power minus 3t, e power minus 3 tau. U of t minus u of t minus 2 will be u of tau minus u of tau minus 2. Okay. And this term, e power minus t, this is h of t tau. So I will be replacing t with t minus tau. So I have e power minus t minus tau into u of t minus tau into d tau. Got it? It's clear?
Excuse me, ma'am.
Yes.
Ma'am, it should be e power minus 3 tau u of tau minus of e power minus t tau u of tau minus 2, right, ma'am? Like they have given bracket for complete, no, ma'am?
Tell me once again. It's
Ma'am, like
your,
e power minus t tau is multiplied to both the terms, right, ma'am?
yeah, you can take a bracket. Okay.
Okay, ma'am.
So is it clear? So now we'll try to group these two e power terms. Okay. So if you group that, what you get? Y of t will be equal to, try to get that e power minus t outside. So e power minus t into integral minus infinity to infinity e power minus 3 tau into plus tau, what you get? E power minus 3 tau into e power plus tau, what you get? E power minus 2 tau, right? Yes or no? Just we are splitting this and we are trying to group these two tau terms. E power tau terms we have grouped. E power minus t term we have taken it out. So here you have e power minus 3 tau and e power plus tau. So e power minus 3 tau plus e power tau will be e power minus 2 tau. Yes or no?
Yes, ma'am.
Into u of tau minus u of tau minus 2 into u of tau t minus tau into u of t minus tau into d tau. Clear? Is this step clear, everyone?
Yes, ma'am.
So now the integral value will depend on these two functions, this function and this function. So try to plot this u of tau minus u of tau minus 2 and you plot u of t minus tau. So we shall try plotting this. So u of tau is nothing but u of t, unit step. Okay. U of tau will exist from 0 and it will go up to infinity with an amplitude 1. Okay, and u of tau minus 2, from where it will start and where it will end? U of tau minus 2. U of tau minus 2, right shift or left shift?
Right shift, ma'am.
Right shift, and it will start from
+2.
plus 2 and it will go up to infinity. Okay, so if you subtract these two signals, what you will get? U of tau minus u of tau minus 2. It is like u of t minus u of t minus 2. You subtract these two, at 0 you have 1 here, here you have 0 here. So 1 minus 0, it will be 1 only. At 2, you have 1 here, here also 1. So at 2, it will become 0. Okay, so the signal will exist from 0 to 2 with an amplitude 1. Got it? Now try to plot u of t minus tau. U of t minus tau, how you will plot it?
Minus infinity to tau.
Yeah. Minus infinity to
T, ma'am, T.
t. So this will be u of t minus tau. Okay. So it will be from minus infinity to t. We don't know that value of t. So these two are our waveforms of our interest. Okay. So So we have to give condition on t. So first this waveform is fixed. We are fixing this u of tau minus 2 and we'll vary this waveform. Okay. So we are fixing this and varying this. Keep that in mind. So what is the first case? I think this t is too long here. Okay, that is fine. Or I'll redraw this.
Ma'am, T is just a constant, right?
Yeah, it's just a constant. You can take from like however you want, you can take. Okay, this is t. We don't know it's what is the t. That t might be anything, just a constant. Okay, just for your reference, I'm taking like this. So case 1 you take. What is case 1? You fix this and vary this with respect to t. So what is the first case? Imagine you have this block. This block you're dragging upon this. Okay, this waveform is going from here to here. Okay, imagine like that. This is fixed. This you're varying upon this. Okay, so what is the case 1?
And t equal to plus 2.
When t is less than 0, right? Why plus 2? We will see that. We are dragging
0,
this
ma'am.
t. We are dragging this t from less than 0, from greater than 0, from greater than 2. Okay, see, imagine this is a block, this is one block, this block is fixed. Okay, this is fixed. This block I am getting on this. Just imagine this is one train. Upon that, like overlapping to that, something is passing. Okay, so when t is less than 0, what is y of t? Imagine t less than 0.
0,
So what
ma'am.
you get? So I have a waveform from 0 to 2 that is fixed. I am getting one more waveform from minus infinity to t, and my case is t less than 0. T is less than 0, so there is no overlapping space here, so y of t is 0. Okay. So next case, you take case 2, you take t is greater than 1 or equal to 0. Sorry, t is greater than or equal to 0 and it is less than 2 you take. So when t is greater than or equal to 0 but it is less than 2. Okay, that means where is t? 0 to 2. This is my waveform. T is greater than or equal to 0 but it is less than 2. That means I will imagine my t is near 1. Just imagination. So what is the overlapping space? If we assume t is between 0 to 2, what is the overlapping space? This is the overlapping
0 to
space.
t, ma'am.
0 to t is the overlapping space, correct? So your y of t will be equal to integral. Okay, we have e power minus t term also. E power minus t integral 0 to t e power minus 2 tau into d tau. Solve this integral. So this is the overlapping space if t is between 0 to 2. So t is greater than or equal to 0. It is greater than 0 but it's less than 2. You imagine like that. That means it will be near 1 you think. 1 or 1.5 anything. So overlapping space is 0 to t. It depends on t where it is there. Okay. So this will be the overlapping space if you imagine if t is near 1. So overlapping space is from 0 to t. Okay. So we have taken our integral 0 to t. Now try to solve this. You have e power minus t. An integration of e power minus 2 tau with respect to d tau will be e power minus 2 tau by minus 2 with limits 0 to t. So what will you get if you solve it? You take e power minus t by minus 2, e power minus 2t minus 1. Yes or no?
Yes, ma'am.
Or you can simplify that one step further. You will have 1 by 2 into e power minus t minus e power minus 3. Okay. This is your y of t. Case 2. Understood everyone? We have e power minus t integral 0 to t e power minus 2 tau into 1 into d tau. Okay, because that amplitudes are of unit step is 1. I didn't take that. You can just ignore it's 1, right? So e power minus t into, integrate this with respect to d tau. E power minus 2 tau by minus 2 with limits 0 to t. So I'll take this 2 here, e power minus t by minus 2. For this e power minus 2 tau, put upper limit and lower limit. If you put upper limit, you'll have e power minus 2t. If you put lower limit, it will be 0. E power 0 is 1. So this I can write half into, if you multiply this by half, this term will come here and this will go here. That's all. Half into e power minus t minus e power minus 3t. Because if you multiply e power minus t into e power minus 2t, you'll get e power minus 3t. Understood? Case 2, everyone? Y of t is half into e power minus t minus e power minus 3t when t is between 0 to 2. Got it? Clear? Case 3 you take when t is greater than 2. So your signal is u of
Greater than or equal to 2, no ma'am?
greater than you take, better. Last case. It has exceeded
So
that.
not equal to 2. T greater
Wait.
than or equal to 2.
See, this waveform is fixed. Sorry, this waveform is fixed. First, this t will be less than 0. Then it will be between 0 to 2. Then it will be greater than 2. Okay. You are varying this t. First it is here, then it is here, and it is here. It is moving upon this. Okay. Last case you take t greater than 2. Okay. So it is 0 to 2 with an amplitude 1. And your t is greater than 2 means it is existing from minus infinity to t. So what is the overlapping space?
But we didn't took any
0 to 2.
condition that t is equal to 2.
Yes. Come again.
We didn't took any condition where t is equal to 2. No. We took less than 2 and greater than 2, but not equal to 2. No.
Okay, you take this greater than or equal to 2 only. What is the overlapping space?
0 to 2.
0 to 2. Okay. So y of t is equal to e power minus t integral 0 to 2 e power minus 2 tau into d tau. Okay. So try to solve this e power minus t into e power minus 2 tau by minus 2 with limits 0 to 2. What do you get? Tell me what you will get.
Half into e power minus t of 1 minus e power minus 4.
Yeah. So if you take e power minus t by minus 2, you will have e power minus 4 minus 1. So you can take half into 1 minute. You can take half into e power minus t into 1 minus e power minus 4. Correct? Y of t. Clear, everyone? So is it clear or not?
Yes, ma'am.
Clear, ma'am.
Okay, so if you have one sequence finite and other sequence infinite, did you see the three cases how we have taken? Understood, everyone? You have to overlap that. You are moving some block on one other block. You have to imagine like that. First t will be less than or equal to 0, then it will be in between 0 to 2, then t greater than or equal to 2, as your people said. Got it? Is it clear, everyone?
Yes, ma'am.
So now at the last you write output y of t is equal to 0 when t is less than 0. Then you can write half into e power minus t minus e power minus 3t when t is between 0 to 2. Okay. Then you can take its half into e power minus t into 1 minus e power minus 4 when t is greater than 2. Got it, everyone? So there are three cases. If one is finite, one is infinite. Clear? Is it clear, everyone? You can take like this also. Okay? Understood? At the end, you write the three cases. Fine? So, is it clear, guys, this problem? Everyone? So, shall we solve one problem with both finite cases? Shall we solve one more problem or enough for today?
Enough for today, ma'am.
Okay. So we'll solve both finite sequences in next class. Okay. Tomorrow's class we can solve that. Okay, guys, you can write your name and USN and we can wind up this session. You have any doubts, means you can clarify. You have any doubts? So if both are finite sequences, how many cases you will have?
5 cases.
We'll have 5 cases. Okay, we shall see that in tomorrow's class. Okay, guys, if you don't have any doubts, then we can wind up this session. If you have any doubts, you can please get it clarified. Thank you, students.
Thank you, ma'am.
Ma'am, ಇದು third chapter, ma'am.
Thank you, ma'am.
Yes, this is unit 3. Convolution sum and convolution integral. Still there is topics left in unit 2. I will do that. Okay. Because I started convolution sum, I thought I will complete of integral also because it will be easy to understand.